Section 3.1, lines and angles. So looking at a lot of definitions, making sure we're all on the same page using common vocabulary, and that when we say certain words, everyone knows what we are talking about. Parallel lines, they are coplanar. They have to exist in the same plane, and they do not intersect. So those two things, that conjunction, coplanar and do not intersect, both of those must be true. Perpendicular lines intersect at 90 degrees. Notice how it does not say they have to be coplanar. Skew lines, not coplanar. Skew lines are not parallel and do not intersect. So these lines have like nothing in common with each other whatsoever. They're on different altitudes, going different ways. They never know each other exists. And then parallel planes, planes that do not intersect. So parallel kind of stacked one on top of the other with some space in between. So identify each of the following using the figure below. Of course, you could find different ones than what I'm going to write because there is more than one example. But a pair of parallel segments, I'm going to go with the top surface there. I'm going to go with BE in the front and CD in the back. They have two sets of wings on them, denoting that they are parallel. So line segment BE and line segment CD. A pair of skew segments, lines that have nothing in common. So one from the top and one from the bottom, going in completely different directions. So I'll say BE, which is going left to right, and then JH in the bottom, that's going front to back. A pair of perpendicular segments. I'm going to go ahead and cop out and just go with the one right here where they put the little right angle marker. So line segment BF and line segment FJ. And then lastly, a pair of parallel planes. Say that 5 times fast. Pair of parallel planes, pair of parallel planes, pair of parallel planes, pair of parallel planes, pair of parallel planes. I did it. So parallel planes, let's go top and bottom. Let's say plane BCE and let's go with the bottom FGJ. Remember, you need 3 points to denote a plane. So of course you may have gotten different answers than me. If you're concerned, go ahead and check with me and I can let you know whether those are good or not. Now looking at specific angle pairs, this is something we're going to be doing a whole lot with this chapter and of course, later on throughout the year. This is a pretty big topic, these angle pairs. Angle pairs formed by a transversal. So a line that intersects 2 other lines. That is a transversal. And whenever 2 lines get intersected by a transversal, you get 8 different angles. Now, in between the 2 lines is the interior. Outside of the 2 lines is the exterior. And then the line that connects them, that is the transversal. So 8 angles get formed, and we can identify some specific angle pairs. So corresponding angles, what I like to say is they are in the same location as each other. So 2 angles that are both in the top left of each intersection. So for example, 1 and 5. They're both in the top left of their intersection. Alternate interior angles. Those are going to be on different sides of the transversal, so alternating sides, so different sides of the transversal, and then interior, inside the 2 lines. So that would be like 3 and 6, also 4 and 5. Opposite sides of the transversal, but in between the 2 lines. Alternate exterior, so alternate, opposite sides of the transversal, but then in the exterior, outside the 2 lines. So 1 and 8, 1's on the left, 8 is on the right, and then they're both in the exterior, or 2 and 7. And then same side interior. Really, these are describing the location. Same side of the transversal, interior in between the lines. So 3 and 5, or 4 and 6. So if we look at example 2, identify the transversal and classify each angle pair. So angles 1 and 3. So if I look at angles 1 and 3, okay, the transversal should be the line that they have in common with each other. So the line that 1 and 3 have in common with each other would be line L. And then what type of angle pair are they? Corresponding, alternate interior, alternate exterior, same side interior. Well, if I look, they're on the same side of the transversal, but they are not in between lines M and N. Angle 1 is in the bottom left corner of its intersection. Angle 3 is also in the bottom left corner. So these would be corresponding angles. They're in the same location as each other. So we did that angle pair in red. Blue, angles 2 and 6. 2 and 6. So what is the line that those two angles have in common with each other? That is our transversal. And if you look, the line they have in common with each other would be line N. And then the type of angle pair. So angle 2 is to the right of N, angle 6 is to the left, so they are alternate. And then they are in between L and M. They're in the interior. So alt, int, angles, alternate interior angles. Example C, let's do this in green, 4 and 6. So 4 and 6, the line that they have in common with each other, they're transversal, is line M. They have line M in common with each other. They're on opposite sides of line M, and then they are outside of N and L. So opposite sides and outside, alt, ext, angles, alternate exterior angles. So make sure you can fit the definition, where are they relative to each other, and then apply the proper vocabulary.